Okay, so the first example that you guys can see here for 7-4, they have 3 to the 6th power divided by 3 to the 2nd power. So, again, 3 to the 6th, that means 3 times itself 6 times. So you'd have 3 times 3 times 3 times 3 times 3 times 3. And then 3 to the 2nd would just be 3 times 3. So what you could notice here is you could cancel some of these 3's. Like this 3 on the top and this 3 on the bottom, those would cancel out and make 1. Okay, any number divided by itself is 1. And again, this 3 in the numerator and this 3 in the denominator would cancel out. So then all you would end up with would just be 3 to the 4th power. So then what did I do with the powers then? How would you use the 6th power and the 2nd power? How would you come up with the 4th power?
You subtract them?
Yeah, good. Yeah, you take the numerator power minus the denominator power. So the rule for this would look like you would do 3 to the 6th power minus, well, it'd be 3 to the 6th minus 2 power. So then what do you do with the exponents? You subtract them. So let's fill that in here. All right, so you subtract them. Now, if I write you a general rule for this, they call it a quotient of powers. It would look like this. You would have like a to the m power divided by a to the n power. So you have the same base. You have the same base in the numerator and denominator. And then what you would do is you would end up with that same base, a, and then the exponent would be the numerator power minus the denominator power. Well, let's see if we can use this then to do these 4 examples. So the first one, maybe I'll zoom in here a little bit. So the first one, you would have just 2 to the 7th power, well, 2 to the 7 minus 2 power. Again, it's always the numerator power minus the denominator power. So you'd end up with 2 to the 5th, which is just 2 times 2 times 2 times 2 times 2 would be 32. All right. The next one is the same idea, but this time the base is not a number, it's a variable. But you would still just do the same base, and then the power would be the numerator exponent minus the denominator exponent. Well, that's just going to give you x to the first, which is just x. All right, and then the third one there. So the third one, the first thing you'd have to do is you'd have to use one of the rules from yesterday. So what you'd want to do is that 2nd power in the denominator, that is a product to a power, so this exponent would have to go on the D and on the E. So then this one would become D to the 4th E cubed in the numerator over. And then if I apply that exponent of 2 in the denominator, that would give me a D squared and an E squared. Well, now you're going to apply today's rule for the d's. So that's going to be d to the numerator power minus denominator power. Same thing with the e's. You're going to end up with an e to the numerator exponent minus the denominator exponent. So that would look like you would have d to the 4 minus 2 power, and then you'd have times e to the 3 minus 2 power. So you just end up with d squared e, or e to the first. So that's number 3. Let's look at number 4. Again, if you guys need something, just unmute and stop me, okay? Okay, so this is number 4 here. Well, the first thing is the power on the 3 in the numerator is a 1, okay? So that's going to give you 3 to the numerator power minus denominator power times 4 to the numerator power minus the denominator power, and then times 5 to the numerator power minus the denominator power. Okay? So that's not too bad. So then we'd end up with 3 to the, well, 1 minus 2 would give you a negative 1. And then 4, well, the 3 minus 4, that's another negative 1 exponent. And then times 5 to the 5 minus 3 is 2. So 5 to the second power. All right, well, you can't leave your answers with negative exponents. So what do you like to do? What do you have to do whenever you see a negative exponent? Aiden, do you know? What do you do when you have a negative exponent? You don't know? It's the little video I played you on Monday.
Move it.
Yeah. Aiden, that's amazing how you threw your voice over to another person. Perhaps you should put the drumsticks down. That would probably help. Yeah, you got to move it. So if you have a negative exponent, remember that doesn't mean the answer is positive or negative. It means you move it. It's a notational thing. So if it's in the numerator with a negative exponent, you have to move it to the denominator and change the power from negative to positive. So that means this one you're going to go, the 5 squared is going to stay on top, okay? If the power is positive, leave it where it's at. So you're going to have 5 squared up on top. The 3 to the negative 1 power, you're going to move that to the denominator and change the power from negative to positive. And the 4 to the negative 1 power, you're going to move that to the denominator and change the power from negative to positive. So then you should end up with 5 squared in the numerator. That's 5 times 5 is 25. And then the denominator, you got 3 times 4 is 12. So your final answer is 25 over 12. Now let me show you another way to think of this problem, okay? If you're ever taking the ACT or something like that and you're like, if you can't remember the rules, what I want you to do is I want you to, no, I don't want you to write this out. I want you to visualize the problem in your head like this. So let's take a look at this. So if you took this original problem, in your mind, you could see it as, you've got in the numerator, you got 3 times 4 times 4 times 4 times 5 times 5 times 5 times 5 times 5. And in the denominator, you got 3 times 3, and then you got 4 times 4 times 4 times 4, and then 5 times 5 times 5. Now, I don't expect you to write it out like that, but that's how you could visualize it in your mind. Well, then what you could do is you could just start canceling these things. Because 3 over 3, that's 1. All right? Now, if you thought about the 4s, you got one more 4 on the bottom than you do in the numerator, right? So that's going to leave you a 4 on the bottom. And then on the 5s, you have 2 more 5s being multiplied together in the numerator. So then you could kind of visualize in your mind, you could visualize these 5s canceling out because 5 over 5 is 1. So if you do that, if you look in the numerator, all you have left is 5 times 5. And in the denominator, all you have left is the 3 times the 4. Everything else that canceled out in the denominator would be a 1. And you can see that puts you right at this point that we were at right here. Same thing. Okay? Well, let's keep going here. So the next thing they talk about is they talk about scientific notation. And they want us to divide these two numbers that are in scientific notation. So let's take a look at that. So what that would look like is you would have 3 times 10 to the 10th over 6 times 10 to the 6th. Okay, so what you do there then is you just divide the numbers. So you do 3 divided by 6. That's going to be 1/2 or 0.5. And then that would be times 10 to the, and then you use today's rule. Because you would take the numerator power minus the denominator power because they both have base 10. So this would be to the 10 minus 6 power. So you end up with 0.5 times 10 to the 4th power. But then technically that number is not in scientific notation. To be in scientific notation, you need 1 digit to the left of the decimal point. So that means you're going to need to move this decimal point over here. All right? Well, if I do that, that's going to give me 5.0 times 10 to the negative 1. All right? When I move the decimal place if I move the decimal point 1 place to the right, it's going to be times 10 to the negative 1 power. It's a negative power because I move the decimal to the right. But then that's still times 10 to the 4th. We still had times 10 to the 4th right here. Well, now to get a final answer on this one then, let me slide over here a little bit. So to get a final answer, I've got 5.0 times 10 to the, well, now you use the rule from yesterday. Okay? If you're multiplying with like bases of 10, then you add these powers. So that's just negative 1 plus 4, so that's going to be to the 3rd power. All right? We got to do the same thing on the next example. So they give us a word problem here. So on this one, they want us to, let's see, the education department spends this much money on this many students. So they just want to know how much did they spend per student, for each student. So we're just going to divide. So we're going to do 4.408 times 10 to the ninth divided by 7.6 times 10 to the fifth. Well, I'm going to do the same thing I did on the last one. I'm going to divide the numbers first right here. So you guys are going to use your calculator for that. So we're going to do 4.408 divided by 7.6. That gives us 58 hundredths, or 0.58. And then that would be times 10 to the, well, again, we have like bases of 10 here, and we're dividing. So we're going to subtract the numerator power minus the denominator power. So 9 minus 5 is 4. So this would be to the fourth power. But then, just like the last example, that is technically not in scientific notation because I need to move this decimal point. In scientific notation, I have to have one digit to the left of the decimal. So if I do that again, that's going to give me 5.8 times 10 to the negative 1. Again, that's a negative power because I move the decimal to the right one spot. But then that still times the 10 to the fourth. So just like the last one, I'm going to end up with 5.8 times 10 to the, well, again, if I've got like bases and I'm multiplying the 10 to the power of negative 1 times 10 to the fourth, that means I have to add these powers. So that gives me 10 to the third power. All right, so let me get a drink of water here. One more exponent rule before we go on winter break. Josh, you should have your camera on. So should Ethan. So should Vanessa. And then let's see, what happened to Aiden? Oh, he's down there. I got you. Vanessa, you're supposed to have your camera on. So let's do this last example. So this last one, they call it quotient of a product. And really what it is it's just a fraction to a power, okay? So you got the fraction 3/4 raised to a power. Well, if you have 3/4 cubed, you guys know that means 3/4 times itself 3 times. So you have 3/4 times 3/4 times 3/4. So what you really have there then is you really have 3 to the third power over 4 to the third power. All right, because you got 3 times 3 times 3 in the numerator, that's 3 to the third. You got 4 times 4 times 4 in the denominator, that's 4 to the third. So really what you had to do then is you had to put this power on the numerator and take that exponent and put that power on the denominator. Hold on, I gotta let somebody in real quick. All right. So then they got this blank over here. It says, what did we do with the exponents? Let's see if I can fit this in here. Well, I don't know, we put the exponent on the numerator and the denominator. So we put the exponent on the numerator and denominator. All right? So then if I gave you a general rule for that one, again, they call it a quotient of a product. That seems like that's the wrong name for that. But I'm going to write the general rule for you guys. So this one would look something like we would have A over, hold on one second. So we would have A over B to the n power. That would equal the numerator to the n power over the denominator to the n power. All right, so let's take a look at the next page. Those will be our last examples here we got to do before winter break. So turn to the next page. And we got to do these 6 examples up here at the top. So let me kind of zoom in on those a little bit. All right, so here we go, number 7. All we got to do is put that exponent onto the numerator and onto the denominator. So if we do that, we're just going to end up with 4 to the second power over 7 to the second power. 4 to the second, that's 16. 7 times 7 is 49. So he gets 16 over 49. Let's take a look at number 8. So number 8, I'll kind of write this out with a little more detail. So what you're going to do is you're going to put the power on the numerator. So that would look like you would have 3d squared to the 4th power over EF to the 4th power. Well, what does that mean? That means you're just going to apply that power to the 3 and to the d squared and to the E and to the F. So that's going to look like 3 to the 4th, d squared to the 4th, over e to the 4th, times f to the 4th. All right. So then that's going to give us 3 to the 4th. That's 3 times 3 times 3 times 3. I think that's 81. And then for this one right here, the d squared to the 4th, you're going to have to use the rule from yesterday. So that's where you have a power raised to a power, so you're going to multiply those exponents. So that's going to give you a d to the 8th. And then in the denominator, you're just going to have a e to the 4th times an f to the 4th. So that's number 8. So we got 4 more to go, and then we go on winter break. All right. So number 9. Again, on number 9 here, I'm going to put the second power onto the 2 and onto the x cubed, and I'm going to put it on the denominator right there. So then that's going to look like 2 to the second power, x cubed to the second power. And in the denominator, I'm going to have xy cubed, that whole thing to the oops, I put that in the wrong spot. Hold on. I'm going to have xy cubed, that whole thing to the second power. All right, well, I got 2 squared, that's 4. Then right here, I have to multiply the exponents. So that's going to give me x to the 6th. And then in the denominator, I've got a power raised to a power again right here, so I'm going to multiply these powers. So that's going to give me xy to the 6th. And really, these rules this week, they can be applied in almost in any order as long as you do them correctly. I'm just choosing to go in this order. Well, now down here in the denominator, you have a product to a power. Well, that means you're going to have to take this 6th power and put it on the x and the y. So then that's going to give you 4x to the 6th over x to the 6th times y to the 6th. Now, can anybody tell me what's going to happen to these x to the 6th right here? What's anything divided by itself? Somebody's got to unmute and tell me. Anything divided by itself is what?
1.
Yeah, it's 1. Thank you. Yeah, that's 1. Now, if you didn't notice that, you might have applied the rule from today. And you might have said, oh, I've got x to the 6th over x to the 6th. All right. Well, I have those like bases, right? I have division where both of the bases are x. So then I would have x to the numerator power minus the denominator power. Well, that would give me x to the 0 power. What's x to the 0 power equal?
One.
Yeah, it's 1. So that's kind of a little, this thing right here. I told you later on in the chapter I was going to show you why. That shows you why if you have any number to the 0 power, it equals 1. Now, you would not have to write all that out. So let me erase this stuff. And you could have just looked at this thing right here and you could have just said, oh, sorry. I didn't mean to undo that. You could have just looked at this and you could have just said, well, I've got x to the 6th over x to the 6th, and anything divided by itself is 1, and you could have just canceled that out right there. So then your final answer, well, all you got left on top is 4, and on the bottom, you just got y to the 6th. All right, 3 more to go. And then we go on winter break. So here's number 10. So again, I'm going to put this power onto the numerator and onto the denominator. So that's going to give me 3 to the, hold on. That's going to give me 3 to the negative 3 power over 4 to the negative 3 power. Again, you can't have any answers with negative exponents. So what do I got to do? Whenever you see a negative exponent, what do you do?
Move them.
Yeah, you got to move it. All right, so that's just going to give you the 3 in the numerator. That's going to go to the denominator, and you change the power from negative to positive. And then if it's in the denominator with a negative power, you move it to the numerator, so the 4 goes up on top, and you change the power from negative to positive. So then your final answer is 4 times 4 times 4. I think that's 64. Over 3 times 3 times 3 is 27. All right, let's do number 11. 2 more to go. So again, on this one, that negative 2 power is going to go onto the 2. It's going to go onto the x squared, and it's going to go onto the y cubed. So that's going to look like 2 to the negative 2 power. Then we're going to have x squared to the negative 2 power. And in the denominator, we're going to have y cubed to the negative 2 power. All right, so let's take care of this part first. When you have a power raised to a power, we're going to multiply those exponents. Same thing here, we're going to multiply these exponents. So that's going to give us 2 to the negative 2 power. And then that's going to give us an x to the 2 times negative 2 is negative 4 power. And that's going to be over y to the 3 times negative 2 is negative 6 power. And again, just like the last one, when I have negative powers, I have to move it. So that means that this 2 is going to go on the bottom, change the power from negative to positive. The x is going to go on the bottom, change the power from negative to positive. And the y, it's in the denominator, it's going to move to the numerator, and you're going to change the power from negative to positive. So your final answer on this one is going to be y to the 6th up top. And then 2 squared is 4, so you get 4x to the 4th on the, or in the denominator. All right, one more to go. So last example before winter break. This one I'm going to leave myself some room. This one's kind of messy. So this one, again, we're going to put this negative 2 power onto the numerator and the denominator. And then we're going to put this negative 3 power onto the 6, onto the m, onto the 2, and onto the n. So that's going to give me, in the first fraction there, I'm going to have 2 to the negative 2 over 3 to the negative 2. And then the second fraction, I'm going to have 6 to the negative 3 power, m to the negative 3 power. And in the denominator, I'll have 2 to the negative 3 power, and I'll have n to the negative 3 power. All right, and again, you don't have to do these rules. Again, these rules that I've given you this week, you can do them in any order you want, as long as you do them correctly. But I'm going to choose to go that way. And then I'm just going to move everything right now. So if it's in the denominator with a negative power, put it on top, change the power to from negative to positive. All right. If it's in the numerator with a negative power, put it in the denominator, change the power from negative to positive. So let's do that. So I'm going to come over here. So up here, I'm going to, let's see, what am I going to do? Well, I'm going to have the 2 to the negative 2 is going to go on the bottom as 2 squared. The 6 to the negative 3 power, that's going to go on the bottom as 6 cubed. And the m to the negative 3 power, that's going to go onto the bottom as m to the 3rd. Then in the numerator, I'm going to have the 3 to the negative 2 power. That's going to go up to the top as 3 to the positive 2 power. The 2 to the negative 3, that's going to go to the numerator as 2 cubed. And then the n to the negative 3rd is going to go on top as n to the positive 3. All right. Well, then you might notice that right here, you could cancel some stuff, right? That would be a 2 times 2 times 2 in the numerator and a 2 times 2 in the denominator, and these would cancel out. Or you could just subtract the powers. It'd be 2 to the 3 minus 2 power. But if you do it the way I did there, what you would do is you would say these would cancel out, and that would leave me a 2 to the first on the top. All right, so what do I have now? I have got a 3 squared in the numerator, that's a 9. I've got a 2 to the first power, so that's times 2, times n to the third. And in the denominator, the 2 squared cancels out, so that's a 1. And then I got a 6 to the third power. Well, 6 to the third power, that is 216. And then I've got a m to the third. All right, let's keep going. So maybe I'll come up here. Almost done. So if I come up there, I got 9 times 2 in the numerator, that's 18. And then I've got a n to the third. And then in the denominator here, I got a 216 and a m to the third. Well, I'm going to try to reduce that fraction. So the first thing I'm going to do is see if 18 divides evenly into 216. So 216 divided by 18, that is 12. So yes, it does go in evenly. So what I'm going to do then is I'm going to divide this 18 in the numerator by 18. And I'm going to divide this 216 in the denominator by 18. And that's going to reduce that fraction for me. So if I do that, I finally get my answer here. 18 divided by 18, that's 1. And then I'd have an n to the third in the numerator. And in the denominator, 216 divided by 18, that is 12. So I would have a 12 m to the third. Now, I don't need that 1 in front of that n cubed. So I'm just going to write n to the third over 12 m to the third. And that is my final answer of my final example before winter break. So again, you guys remember over winter break later on today, in today's folder for December 18th, I'll post some extra credit for you guys. That will not be due till if we come back in person on the week of January 11th. Also, make sure over the break, if you have any zeros or any assignments that are missing on PowerSchool, make sure you do those and submit them to me on Schoology. Let me write your assignment down for you real quick. So your assignment is, it's on page 486. You have got numbers 25 through 45. And then also numbers 50 through 53.